I start with my input. I notice that there's no horizontal transformation, so I square it. Then we're following order of operations. So making the graph 4 times as tall, I do by multiplying by 4, which happens before addition or subtraction, right? So multiply by 4, and then shift up 1 by adding 1. On this next one, I want to go 3 units right and reflect it across the x-axis. Again, this one's vertical. This one is horizontal. So we start with our input. There is a horizontal transformation. It's a shift to the right, which means I subtract 3. Again, I haven't squared it yet because I'm working on the horizontal transformation. Now I'm ready for the vertical. So we square what we had. And then to flip it across the x-axis, what do I do? Just negative in front. Okay, you guys try C and D real quick.
So how did you know that, like, on the second one it was horizontal and vertical? How do you know that?
Well, because right and left is like a horizontal movement.
Oh.
And flipping up and down is a vertical movement. So it's just in the way they describe it. Okay, Kenny, what will it look like if we just reflect the graph across the x-axis and make it half as tall? Where? Like right here? We're going to call it a fraction just because that way if it was a third, it wouldn't be rounded. But yes. So we multiply to make it half as tall, and we multiply by -1 to flip it. So there's no shifting here, right? There's no addition or subtraction because we didn't go up or down or left or right. We just compressed it and flipped it, both of which we achieved through multiplication. Dylan, what about D?
X plus 5.
Yeah.
Parentheses.
Uh-huh.
Square that and then subtract 2.
Perfect. Good. So we went left 5. That was a horizontal transformation, so that is inside the parentheses. Then we square it. Then we go down 2. Very good. Don't forget your exponent. Like, it might seem silly, but that was the biggest mistake people made on the test. The last time I put one of these problems on a test was like forgetting to like actually put the squared on there, because that's the obvious part and the rest is the hard part. So just don't forget to get your exponent on there, because then it won't be a quadratic if it's not there. Does this make sense? Okay. So our focus for today is going to be mainly on the factored form of a quadratic function. So remember from Friday, we said there was a relationship between factored form and the x-intercepts of a function. On Friday, we mostly looked at the equation of the function and figured out what the x-intercepts were based on that. We're going to go the other direction this time. So if M0 and N0 are x-intercepts of f of x. Another way of saying that is that the solutions to f of x equals 0 are x equals m and x equals n. So we could give you that information in one of two ways, right? We could give you it, say the solutions are m and n, or we could say the x-intercepts are m0 and n0, and those both say the same thing. So if that's the case, then f of x equals a times x minus m times x minus n. So we can write the function in factored form if we know what the x-intercepts are. We need another point to figure out what a is, but we can at least get the two factors from our x-intercepts. So if I am given the x-intercepts of a function and I want to write the function, so an expression for my function, I can say f of x equals, don't forget your a, and then, so we know that x equals -6, and so the factor that corresponds to that we can get just by setting that equal to 0, right? If you add 6 to both sides, you get x plus 6 equals 0, and so x plus 6 is the factor. And if x equals 2, I can subtract 2 from both sides to get 0, which means that x minus 2 is a factor. We're basically doing the process of solving by factoring backwards. Like normally, if we were solving this by factoring, if we set it equal to 0, we would say that x plus 6 equals 0, which would lead us to x equals -6, right? So we just did that backwards. And same with the x minus 2. If we had the equation, we would set x minus 2 equal to 0, which would give us x equals 2. So we're just doing that process backwards to find our factors. And then I'm not quite done yet because I don't know what a is, but we can use a third point to find it. So just like we did on Friday, we can plug in 0 and 1 for my input and my output and solve for a. So my output, that whole thing is 1. And my input is 0. Don't try to distribute here. Remember order of operations. We know what 0 plus 6 is, right? There's no need to start doing like all sorts of multiplying. Just simplify inside your parentheses first. And we get 1 equals -12a. And then we'll divide both sides by -12. What's up? Good? Okay. We'll divide both sides by -12. And we're almost there. We just have to write the function now. So we found all the pieces. We're just going to write our function at this point. So f of x equals, my a was -1/12. And my factors were x plus 6 and x minus 2. And you can leave it like that. If we give you the x-intercepts, we expect that you're going to write the function in factored form, and there's no need to simplify from there. You can just leave it factored. Because that's really what we want to see, is that you can get to this point. What's up?
So did you plug in 1 just because that was the right intercept? Or did you go?
No, I was just plugging in this point. So if this had been the point like 4, 7, I would have put a 7 here and like 4s right here.
Okay.
So I was just plugging that point in for x and y.
Does it matter how you put the points?
What do you mean?
Because, like, do you which order you put them in?
Yes, because in ordered pairs, this is your x coordinate and this is your y coordinate,
Oh, okay.
right? So I have to put 0 in for x, and then I have to put 1 in for y, which is my output, so for f of x. Other questions? Okay. I'm going to actually skip this one. I did it in the last class and found that I didn't really like it very much. We didn't really get much from it. So let's do this one instead. This one is exactly like the problem we just did. The only difference is that the information is on a graph instead of written as ordered pairs. One thing to be really careful of when you're given information on a graph is what points you choose to use. Like on Friday, we used the vertex to write the function, but that would maybe be a poor choice here because I'm not 100% sure what that y-coordinate is. Like I could estimate it, but I don't know that I'm going to get that right. Whereas the x-intercepts and the y-intercept are nice integer points, and so those are the ones you would want to pick. I mean, you could get lucky and estimate that y-intercept perfectly, but probably not. So go ahead and use those 3 points and use the procedure that we just used to write a function. And again, just leave it in factored form.
The x and y intercepts are?
Good. Kevin, what next?
And then you pop that into f of x equals a, and then it would be x plus 6 and x minus 2. Or 4, sorry.
No, 2 is right.
Oh, sorry.
It's okay. Yeah, so we use our x-intercepts there. Good. And Kenny, what next?
Now we're gonna plug in the y-intercept.
Okay, what'd you write?
I wrote 4 equals a, 0 minus 6, and then 0 minus 2.
Perfect. So we should end up with 4 equals negative 12a, yeah? And so 4 over negative 12 equals a, which simplifies to what, Nikki? Good. So f of x equals negative 1/3 times x plus 6 times x minus 2. Yeah? It looked like everybody got that pretty quick. So another way we can use this information, this relationship between the x-intercepts and the function or the equation of the function, is to help us factor when the numbers are really, really big. Like, I don't know about you, but if I look at this and I want to factor it, like doing the AC method sounds really, really annoying because it would take forever, right? Like, I'd have to write all these numbers that add or that multiply to 1,728 and figure out which ones add to negative 48. But what we can do is use another method to solve the equation x squared minus 48x minus 1,728 equals 0, which would give us our x-intercepts. And once we know our x-intercepts, we can write this function in factored form, right? So because of the form that this equation is in, I'm going to solve it by completing the square, because the coefficient of x squared is 1, and that middle term is even, which makes completing the square a lot simpler than trying to do the quadratic formula, especially with such big numbers. So remember, to complete the square, the first thing we did was what? Feel free to look back in your notes.
And we divide by x. Like
Kevin, what's up?
Divide 48 by 2 and square it. Does that mean
You do. We have to do one thing first. What is it, guys?
Just move the constant.
Yeah, we're just going to add 1,728 to both sides so that I just have the variables on one side, or all the variable terms on one side and the constant on the other. And then, like Kevin said, we're going to take b, which is the coefficient of x, divide it by 2, and then square it. So we get negative 24 squared, which is 256. And that's the number that we add to both sides to complete our square. So x squared minus 48x plus 256 equals 1,728 plus 256. So then it sort of defeats the purpose of this whole enterprise if we have to use the AC method to factor the left side. But remember that when we complete the square, this number that we squared to get that 256 is the constant term in the binomial that is being squared. So like, we know this factors into x plus something squared, right? This is always that number, so minus 24, right? Because if you imagine multiplying that by itself, that 256 comes from the negative 24 times negative 24, right? And so if you remember that whatever you squared to get the number that you added to both sides is going to be your constant, then you don't actually have to do like the AC method. And so we've avoided that twice already. Yes?
I'm still a little confused as to why you set it over 2 and square it.
So when you multiply like x plus, I don't know, I need a letter, n times x plus n. So if you square a binomial,
Yeah.
you get x squared plus n times x plus n times x plus n squared. And that is x squared plus 2nx plus n squared. So this is the form we want it in because we want it to factor as a binomial times itself, right? So this number, half of that squared, gives me this.
Okay. I see.
So I'm just setting it up so that my trinomial is in the form of a perfect square.
Okay.
So equals, this is a large number, it's like 2,304.
Don't you?
No. 4, 1, 5, 6, 7, 8.
I got 1984.
1980.
Don't you take 1728 plus 256?
Yeah.
Yeah, it's
So that's 4. That's 8. That's 10. That's 2.
I got 1984 on my calculator.
Oh, I see why. Never mind. There was not a 1 to carry right there. Okay. Will somebody tell me what the square root of 1984 is?
44.54.
Somebody square 24 for me.
24 squared is not that.
It's not
No, it's
256?
576.
Thank you. Oh my gosh. It's 16 squared.
I was wondering how you got 24 and we tried to get 24.
576.
You also have to replace the one on the other side.
I will do so. Thank you. Now this is what I want it to be. 7, 8, 9, 6, that's 14. 7, 8, 9, 10.
3 or 4.
Yes, there it is.
I was wondering how you got that.
That's what I wanted it to be, and its square root is 48. Plus or minus the square root of 2304. See, I'm like one of those students who used photo math and then tried to work backwards. Doesn't work. If you don't know what photo math is, it's probably because you haven't been doing your homework. I can always tell when you guys use photo math. Especially when you use like cool mathematical symbols that I've never taught you and you've never seen. So x is equal to 24 plus or minus 48. So we have 24 plus 48, which is 72. And then 24 minus 48, which is negative 24. So my x-intercepts are 72, 0, and negative 24, 0. Which means that my function is a times x minus 72 times x plus 24. What is a?
Is that the edge? Or the, like how wide?
Yeah, so that leading coefficient tells us what the stretch factor is, right? But since we don't know, we don't have a picture of our function, so we don't know from stretching it. But guys, remember that big box that had like the 3 forms of a quadratic function from Friday? What did we find out about a in all 3 forms? That it's always the same, right? So if a is 1 here, then a has to also be 1 down here. So if you already have it in one of the forms, you can just take your a right from that. And that's why we didn't need a second point or a third point to solve for a. So f of x equals x minus 72 and x plus 24. Often, instead of having you do all of this, we just give you the solutions and have you factor it. So, for example, on this one, we said when the quadratic formula is used to solve this equation, whatever it happens to be, the solutions are x equals negative 13 and x equals 49. And so we want to write an algebraic expression for f of x in factored form. This is exactly the same as what we just did. So I'm giving you this information, so you don't have to do all that solving. You're just starting up from that point because I gave you the solutions already. So go ahead and write your function in factored form based on this information.
Plus 13 and parentheses start with the same x minus 49 and parentheses.
You guys all agree? Perfect. So that wasn't too bad when we didn't have to solve for everything, right? So don't get daunted if you see something like this on the test where we just give you those solutions. So we're just starting at sort of the end of that process. Okay, so we, on Friday, we looked at how to find the vertex if we have standard form, right? But putting a function in standard form can be somewhat tedious. We're going to do one just so you can see what it looks like. I'm going to go back to this one that we skipped. And we're not actually going to do everything that it told us to do here, but we're going to just put it in standard form. The way that we do it is we have to complete the square. But we can't set it to 0 because we're not solving for like the x-intercepts or the zeros. We want to keep the function as a function. If you guys like it better, we can call this y. Would you like it better if we called that y? Okay, let's call it y for now. What is the first step to completing the square? Even before moving the constant?
Get x, just x.
X squared? Yeah, we want the coefficient of x squared to be 1, right? So in this case, I have to divide both sides by -1 to get rid of that negative sign. So we have y divided by -1 equals x squared minus 4x plus 7. And now, Nikki, what should I do?
Move 7 to the other side.
Yep. So y over -1 minus 7 equals x squared minus 4x. So see, we're doing the same exact process that we do when we use completing the square to solve an equation. We're just keeping that y there because y isn't necessarily 0 in this case. So what next? Right, we take our b divided by 2 and square it. So -2 squared is 4. So we have y over -1 minus 7 plus 4 equals x squared minus 4x plus 4. So combining like terms over here, I get -3. And then factoring gives me x minus 2 squared. Now my goal here is to put this in standard form, which means I want it to say like f of x equals something. So now that I've completed the square, all that stuff on the left side has to come back over. So I have to solve this for y. How should I go about that? What's the first thing I should do to solve for y?
By -1.
So, I mean, I could multiply by -1, but typically, what do we get rid of first when we're solving? Yeah, the addition, subtraction, right? So if we add 3 to both sides, and now I can move that -1. So I'm going to multiply both sides by -1, and we get y equals negative x minus 2 squared minus 3. Notice that -1 does not get distributed. It's just -1 times x minus 2 squared, and then -1 times that 3. And so now I could get my vertex, right? My vertex is what? Like 3 or something? Is the vertex a number? Yeah. It's an ordered pair, right? So that process is a little bit tedious, like just to find that single point, right? So let's think instead about the relationship between the x-intercepts and the vertex. So we know that the x-intercepts, or the x-coordinates of the x-intercepts, are given by x equals -b plus the square root of b squared minus 4ac over 2a. And x equals -b minus the square root of b squared minus 4ac over 2a. So those are the x-coordinates of my two x-intercepts. This guy and this guy. What can you tell me about the x-coordinate of the vertex in relation to those 2 points?
This is just tell which side of the x-intercept.
Right, so the addition and subtraction tells us which side of the vertex we're on. But Kendall, how's the vertex related to the... It's like right in the middle, right? It's halfway between the two x-intercepts, which means that this x-coordinate should be the average of the x-intercepts. Right? Because to find the number in between two numbers, you just take the average. So, well, let's take the average. Averaging two things is adding them together and dividing that by 2, right? So I'm finding an x-coordinate. I'm going to do negative b plus the square root of b squared minus 4ac over 2a plus negative b minus the square root of b squared minus 4ac over 2a. So I just added my two x-coordinates, and then I'm going to divide it by 2. This looks a whole lot worse than it is, I promise. Because if you look in the numerator, we have common denominators, right? So like to add those, all we have to do is add the numerators. What happens when I add those two radicals? What do I get? I get 0, right? Doesn't matter how messy it is. If one is positive and one is negative, they add to 0. So those go away, which gives me negative 2b, right? Negative b plus negative b over 2a divided by 2. I can cancel those 2's. And we have negative b over a divided by 2, which is the same as negative b over a times 1/2. So we just found the x-coordinate of our vertex. We call this the vertex formula. The x-coordinate of the vertex is given by x equals the opposite of b over 2a. One thing I want to point out, when I've been looking at your guys' homework and stuff, you've been getting a little bit lazy about like setting things equal to 0 and writing like your x equals. Especially when we get into these applications we're going to be doing tomorrow and Wednesday, it's just really important that everything is labeled according to what variable it is, because otherwise you start getting lost. There's a lot of numbers going on. So keep in mind that the quadratic formula is not negative b plus or minus the square root of b squared minus 4ac all over 2a. It is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's a different thing. Like one's an equation and one's an expression, right? So that x equals matters. Same thing here. When you find your vertex, you want to write x equals and use your formula. So there's two sides to it. And keeping that x equals is going to help you figure out what to do with that number once you find it. So I only found half my vertex here, right? I found the x-coordinate. How would I find the y-coordinate?
Isn't it just 0? Because you're only finding that x point, you're not actually...
No, because so like these points have a y-coordinate of 0. But we're talking this point right here. This is the point, negative b over 2a. How do I find the y-coordinate? If you think you know, but you think it's too simple, you're probably right.
Carefully?
Okay, we do everything carefully, yes.
Don't you just plug it in?
Yes.
The equation, just equalize the x. So we're
Yeah, anytime you have an x coordinate, you can find the y coordinate just by plugging it into your function. So we use our formula to find the x coordinate, and then we just use our function to find the corresponding y coordinate. Carefully. I'm going to give you guys back the rest of your papers while you find the vertex of this function. You just use your vertex formula.